Okay, this is unit 1.11 and 1.12, continuity. This kind of follows up from the last lesson, which was about discontinuities. This is the definition of continuous at a point C. You have three conditions that you meet. So for example, you have to have your value defined at C. And again, C could be any arbitrary value. Your second criteria is that the limit from the left and right hand side of C have to be the same, which means it exists. And then thirdly, you have to have steps 1 and 2 agree. Step 1 has to be the same value as step 2. And if those three criteria are met, a function is considered continuous at that point C. Example 1 kind of shows you or highlights the failures, like when you fail any of the steps, what it looks like. For example, the first part, when it says condition 1 is true, so it does exist, but the limit is not, the limits approach different values. So if you look at this case, x equals 1, notice how the function exists at 1 and it is equal to 3, but notice the left and right hand limits are different values. So 1 is true, but 2 is false, and that kind of leads you to a jump discontinuity. If the limits, the left and right hand limits approach different values, it's going to be a jump discontinuity, and it can't be continuous there. So here's condition 2 is true, which is the left and right hand limit approach the same value, which in this case is 2, but we don't exist at 2. The limits can exist, but if the value doesn't exist, it's not continuous. This is considered a whole. And then the third part is kind of similar to this one, where conditions 1 and 2 are true, but 3 does not hold. So, for example, the function does exist at 1. See, it's equal to 3. And the left and right hand limit exists at 2. But notice how these don't agree. These are different values, so it is not continuous. This, again, is a whole or removable discontinuity. And there you go. So let's look at example 2. It says, show that the following function is continuous at x equals 1. So we do need to show these 3 steps. And, just to note, this is kind of the shorthand for writing continuity. Because, again, if the limit exists at C, that must mean number 2 is true. And then obviously f of C has to exist, and then they're equal. So this is your argument, is step 3. That kind of summarizes the argument of continuity. Okay, so at first we need to show that the function at 1 exists. So f of 1 is going to be equal, again, to this equation here. I'm going to highlight it in yellow. And so let's substitute 1. So log of 1 is 0 minus e to the 0. So that's 1. E to the 0 is 1. So 0 minus 1 is negative 1. And now, so condition 1 is true. So we have to show that the limit exists now. So let's do the left and right hand limit. So I'm going to do left hand limit here. Limit as x approaches 1 from the left. We will highlight this in orange. So substitute 1 in for 2x squared minus 3. And so we have 1 squared, which is 1, times 2 is 2. And then we have 2 minus 3 is negative 1. And now we have to show our right hand limit. And just for shorthand, because again, right hand limits are going to use this equation, I'm just going to kind of cheat and put limit as x approaches 1 from the right equals f of 1 equals the equation. So this is sufficient. This is fine to write it like this, because plugging in 1 and approaching 1 from the right both use the same equation. So we do have that the left and right hand limit equal negative 1, and the value is defined at negative 1. So in summary, we could say f of x is continuous at 1, because, and again, I am just going to write this statement here. And I wrote, because the limit as x approaches 1 is equal to the value at 1. Remember, this implies left and right hand limits are the same. And so there is my argument, and I answered the question properly. Okay, example 3. Is the following function continuous at x equals 3? Give a reason for your answer. So again, I'm going to kind of do the same thing I did in example 2. And I'm going to notice that the right-hand limit and the right-hand limit of 3 and equals 3 is the same equation. So I'm going to write that here. Because again, f equals 3 is this equation, and the limit as we approach 3 to the right is the same equation. So let's substitute. And 9 minus 2 times 3 is going to equal 3. So now let's do our left-hand limit. So substituting 3 in for x, that's going to be 3 squared, which is 9, minus 5 is 4. And notice how the limit does not exist because they approach different values. So we can say not continuous because the limit does not exist. And that is sufficient argument. That is a sufficient argument. And just to let you know, this is going to be a jump discontinuity. And I just noticed a mistake. These are supposed to be G. There you go. Be careful with that. Okay, question 4. Find a value of C such the function is continuous for all real numbers. So when I look at this equation, that looks like it will be continuous no matter what, because there's no values that make it undefined. And this is just going to be a constant, because again, C is going to be a number like 1, 2, 3. So this will be a constant, so that's always continuous. So it's kind of the same process. We need to do our left and right hand limits and our values. And similar to the other two problems, we're going to use this top equation for the left-hand limit. And we are substituting 3 in for x here and here. And if I simplify this, I'm going to get 9c minus 6. And then the right-hand limit, we're going to use this equation. And the value at 3 uses the same equation, because this is 5 plus c is what you use for equal to 3 or greater than. And please, please, please do not plug in 3 here. We're going to substitute x equals 3. There is no x to plug in, so this is just going to be 5 plus c. Okay, now, again, both of those should be equal if you want it to be continuous. Let me just write that. We're going to write k of 3 is equal to the limit as x approaches 3 of k of x. And let's substitute in. And then we just solve for c. If you subtract c from both sides, that equals 8c. And then if you add 6 over here, you get 11. And then if I divide by 8, I'm going to get 11 over 8 is my value, is my constant value of c. And so there you go. Good luck, guys.